I guess one way to think about why LLMs are so powerful is because it has like almost infinite recall of information and like things that it could do, but doesn't mean that you have performative recall on everything, right? And so from that perspective, if you want performative recall, you need an agentic software system where you have agents that also could call tools, like basically headless software and agents working together. And from that perspective, naively putting everything into the context window, it's almost tautologically not the thing that you should do. Okay, we're rolling.
Hey, hi everybody.
Welcome to episode 6 of Agentic Data. It's already episode 6, Robert.
Yeah, it's crazy. I feel like we just started this, but we're on 6 already.
Yeah.
It's nice. It's wild.
Yeah, I think we're getting the hang of this.
Yeah, it's fun. It's becoming more automatic.
Yeah, that's good. Let's see the talking points for this week. I guess last Thursday, GPT-5 came out, and I think one of the interesting things that we saw was that, first of all, the context window for GPT-5 is at 256,000 tokens, which is extremely large. And another interesting point is that I think the tapering off of context fidelity is quite high, even at 256,000 tokens. And I think some folks on LinkedIn and other platforms have commented that this might be the end of RAG, which is a very bold claim. I think we've heard this several times.
Yeah.
But is this for real this time? What do you think, Robert?
Yeah, I don't know. It's interesting because the context window is so big now that for most of our customers, we can take all of the queries that they've written and just shove them into the context window and then use those for, a few shot prompting, or like basically like 1,000 shot prompting, right? So I think in some sense, if that's true, if context fidelity has dramatically improved, then maybe this is something to test. But something that feels really weird to me about this, Joseph, is like even for humans, it's when you read like a book, it's not clear what you should be paying attention to, or like what another person would want you to pay attention to when you read the book to answer, say, questions that they have. So like it feels like on the one hand, great, exceptional, but on the other hand, it feels like maybe there's some fundamental problem here about how information is parsed that isn't being taken into consideration by the people that are saying like RAG is dead. Do you know what I mean? Like it feels as though there is some sort of mapping onto semantic space that people naturally have in their brains that determines how they want questions about that space answered and how they want context parsed for them. And this is probably heterogeneous, at least at the user level, but perhaps at the organization level, in that there are patterns for how information should be parsed as well, that make me kind of skeptical that this problem isn't going to go away with simply massive context windows. But I mean, obviously, like we're going to just leverage this, right? Just make the context windows bigger and bigger. There's also questions about cost, right? I imagine as the context window gets bigger, cost and latency to parse all the information, but also to pay for all the tokens is going to be maybe spiral out of control.
But do you think that your intuition about how information is processed is heavily limited by the fact that all software right now is used by humans? So that's the key bottleneck. And also the brains of humans are pretty, low throughput compared to computers. So your intuition is just based on false analogies.
It could be, but I imagine that you could construct like very simple logical experiments, like logical thought experiments even, that would point to fundamental problems with retrieving information from large blocks of time. Like even if you imagine you just have like a list of 5 sentences and all those sentences are contradictory. Maybe there's a way that how you parse that is heterogeneous to the circumstance that you're dealing with, as opposed to there being some sort of specific truth needed to reconcile those statements.
Yeah,
but you can imagine
we could construct pathological examples. Like for example, I think, as a mathematician, I've spent maybe 10 to 20% of my time constructing pathological examples so that you could prove certain things, which may not be helpful in practice, but in real life. But maybe here you go. So I guess if you're trying to answer question Q, let's say, and then let's say, what color is Robert's hair? and then in the full context window, you shove in an entire document, and then part of that is some context poisoning, like Robert's hair is red, Robert's hair is red, Robert's hair is red, and then the remainder of the document is like Robert's hair is black and some other information. So to what degree is bad data detracting from the final answer when the context window is big? And then maybe we could actually get around that by actually, despite having a very large context window, you have a more structured retrieval process that only gets the right information at the right time. And so you could construct pathological context poisoning examples to really get the wrong answer based on the information at hand, because companies are very messy, and if companies are messy, then data is messy, and if data is messy, then you're going to have context poisoning. And so if you just very trivially and naively put that all in, then what's happening is you're actually relying on the large language model itself to be the arbiter of truth in some sense, and then LLMs are just not good arbiters of truth. What is better as an arbiter of truth is structured acquisition and retrieval that serves as the arbiter of context truth, and then the LLM gets to use it. So that's how I would construct a pathological example to disprove this context thesis.
Yeah, that's right. And I imagine it doesn't have to be so. I think there are a lot of practical examples where this could be a problem, right? Like you've told me a lot, Joseph, about how when you were working with Wayfair at Quantco, there were often like multiple definitions of revenue. I think this is like a very common, if you ingest, like if at a big enough company, if there's no single source of truth for a particular definition, or if there's just ambiguity around how that definition, how the thing someone is asking about maps to the definitions that you have, there's certainly there's a need for an arbiter that in your vernacular that has to exist to.
That's right.
To parse all this information.
In the case of imperfect data, which is basically 100% of the time. So I guess practically, if you have imperfect data, you're going by putting everything into the context window, you're almost surely going to have context poisoning, and almost surely context poisoning is going to get to bad results, at least in some domains, like some non-trivial domain in the question and the answer space. And so you could provably show that this is not a good idea in general. Like universally, it's not a good idea. But I guess like let's now reason through, okay, what if the data was actually perfect? Then do we not need RAG? And then it really comes down to, then even if you have all the information, maybe you will get slightly worse results because it's just parsing through too much information. So you're getting information that might be related to the answer that is mixed in. So like, when does concision become a better answer rather than full coverage? So if you know about a topic X, and then you could create like a epsilon ball around that topic X, like in what circumstance do you want to know everything around that ball as the answer, or when do you want concision, right? Like what do you think about that?
Yeah, I mean, it's tough. I could think of examples on both ends, right? Like I think a really canonical one from when I was at Airbnb is like, imagine if there's just ambiguity around the thing that you're asking about. Like imagine you ask, how many listings do we have? But the issue is that a listing at Airbnb is very ambiguously defined, as in like there's listings that are active or not active. There are listings that have been booked or not booked. Those are called, and then there's listings that are like first time booked, which means like the first booking has happened. There are lapsed listings, there's inactive listings, there's deleted listing. Like you could answer that question obviously in any number of ways, but likely the best way to answer it for most use cases is just what's the most popular metric of these metrics that exist, like which one's the most widely accessed, and then take that one and respond with that. Because what someone is looking for when they ask, how many listings do we have, is likely not like an expose on all the different fucking metrics that exist around listings. And so from that perspective, like quick question answer, concision is optimal. But then of course, like depending on the nature of the question, some other questions like what's happening in Australia that's causing our dip in active listings coming out this last week, you probably want a much wider scope of, well, within active listings, there are a few different ways to measure this. And within those few arms, I've also cut it by a bunch of dimensions and come to a few conclusions, a few different hypotheses that could be. This kind of comes back to your taxonomy point from last week, right? There's, depending on what kind of question is being asked, I think kind of naturally maps to concision versus not. And I think that has some bearing on how the retrieval process has to be built to optimize for one or more of those use cases, for that divergence of use cases.
Okay. I came up with two ways to frame this. One is,
Cool.
I think it's building upon what you just said, which is, I think for most cases, because at the end of the day, a human is taking the output and making some decisions based on some data, you do need some concision, because concise statements are both easy to understand and also easy to propagate down in organizations, just because we're all humans, and we need both understandability and also virality of an idea for you to actually be able to command people to do what you want to do. And so from that perspective, I think concision is needed. And then secondly, this is more of a statistical point, but if you do believe that there is a Pareto law in terms of the causality of everything in the universe that you can observe, not in the universe, but in the data universe, in the business universe, then things are probably attributable to a few eigenvectors anyways. So knowing 100 variables is almost the same as knowing just 2 variables that actually truly matter in this business scenario. And this is turtles all the way down. So in every dimension, in every layer, there's like 2 to 3 dimensions that actually truly matter. So having 100 variables and reasoning about those things is not, very effective to begin with. And also, not only from a data analysis perspective, which is a statistical way to think about it, but even from just a resource allocation perspective, we're making this podcast, right? In this podcast, if this is working, we're not going to randomly go and create like some TikToks and like distribute our energy, right? So in general, like people do tend to only focus on things that start to work anyway. So statistically, if you look at the physics, things are probably distributed in Pareto. And just practically, humans are only able to do a few things anyways and focus on a few things anyways. And from that perspective, statistically, practically, and also human brain interface limitation, because of the limitations, you are forced to be concise. And from that perspective, even if you had the largest context window in the world, still being precise is probably good in many dimensions.
That's so interesting. I'm gonna get nerd sniped for a second, but I wonder how many processes in the world are Pareto because humans are involved and we're naturally limited. How many are actually, because obviously some things are power law distributed. Okay, an example is, so obviously avalanches are kind of a canonical example of like a power law distribution of the size. But then on the other hand, so is like, I think it's Zipf's law, which is like the frequency of words in spoken English. But of course, like that one probably is just a direct reflection of our brain's inability to hold too many words in our head. I don't know if you've noticed this, Joseph, but like I find that when I talk to people, I often start to incorporate the vocabulary that we use into my working vocabulary, into like the vocabulary that's in my working memory. So I start to talk like people that I talk to.
Right.
If I talk to them enough.
Right.
And I wonder if that is basically what gives rise to Zipf's law or whatever power laws that you. But the point, just to bring it all back, like the point is like, then of course it naturally makes sense that many of the very natural extension to Zipf's law would be within an organization, certain metrics are important because those are the only metrics that we can keep in our head. We just can't, I can't at least, but I think humans can't keep hundreds of metrics with equal weight in their heads at all times. But I guess this points to another question, which is like, shouldn't like LLMs perhaps have no such limitations? So there is a world where we could just, maybe this naturally brings me to another point, which is like LLMs, there's this question of like, should we be just giving LLMs free reign to look through all of our fucking data and find these like needles in the haystack wherever they might be, as opposed to letting them explore things or follow our existing patterns of construction around the ontology of the business, Right.
I guess if you're using the LLMs to find a needle in the haystack in terms of give me unknown insights from potentially unknown data that I don't really know about and give me some insights I could draw conclusions from, then having a larger context window will certainly help, because you could just put all that in, all of the data in, and then try to reason about it without having a priori knowledge about how things are modeled. But if you're thinking about, you kind of know what you're dealing with in terms of how the data is modeled, and then you're trying to accelerate things that you were doing anyways, like building reports or answering a lot of questions and deflecting them, all these things, then the larger context window won't matter as much. So that's like one way to think about this. And I was just thinking about another thing as you're talking. I guess you could try to remove the human from the equation altogether. Like imagine if the context window, not as it pertains to just data, but like I think you could break up everything a company does into maybe 3 distinct components. One is synthesize information, make decision, and then take action. So that's really everything that a human really does in a company, in an organization. So we're just talking about synthesize information, but what if you could make an agent synthesize the information and then make a decision and take action all in, I guess, one shot, one step, like one agentic sequence? Then the information bottleneck that a human has because they need to make the decision might be gone, right? Like an agent might be able to make a decision based on like a very, very high dimensional vector rather than like a lower dimensional vector. And now this becomes more statistical. Even if that were available, do you think that only a few variables will matter? Certainly, you could do like a PCA, like a principal components analysis, and try to find the eigenvectors in which a rotation of that space is in which only a few eigenvectors, like the dimensions, really matter. So even in that case, it is perhaps possible to rotate the space so that only a few dimensions matter in the first place. And then you take action, and that action space might be very large. Like imagine, like the agent could talk to literally any one of the 7 billion humans on Earth and take some actions. So let's include all the companies in the world. So like you have like 10 billion entities, and then you could choose to do like 1,000 different actions. So that's 1,000 times 10 billion. That's 10 trillion, I guess, pairs of things. That's like the cardinality of the action space. 10 trillion, still finite. It's not super large. And so the agent could act on any one of those 10 trillion pairs and then act on that. So I guess you could construct a system like that, and then like the human could be removed altogether. Now, in that perspective, does the context window being larger help?
Yeah. My God, I have so many things to talk about, Joseph. Like, I mean, you posed this in such a fascinating way. Like, it clearly is. I don't know. It feels like you know what the answer is, right? Like, as machine learning people, originally, you never get to the optimal algorithm by doing PCA first. You get to. Well, sometimes you do, but generally speaking,
it rarely helps. And then actually just doing the naive thing is sometimes better, is what you're trying to say, right?
Yeah, and the naive thing, like almost always in my experience, XGBoost beat linear regression, right?
Right.
And there's this level of like, there was this old idea back when machine learning was at its heyday around, you want to build a model that does something and essentially makes automated decisions at scale, but then at the same time you want it to be explainable.
Right.
But this was a constant tension between stakeholders and the people that build the models, because the people that build the models were like, well, fucking, I can't like do both. Like you need to choose one. Like it can be explainable, but it's not going to be the best algorithm. And at least in my experience, like the best algorithms that I shipped were ones where we were able to make that trade-off explicitly in the direction of let's make the best fucking algorithm.
Right.
Let's ship it and make sure that we just eke out every ounce of performance. This all also points to this very interesting point you're making around like, and I don't have an articulate way of saying this, but like there's this tension between like LLMs. Like this feels like it's the thing that structured data is intended to solve. Like you don't solve. Like, the context window is massive, but that doesn't mean that you would never dump in your entire database into the context window, like the whole table into the context window, right? There's a level of like, yes, maybe the LLM can parse it row by row, but I would be very, very wary to make the bet that LLMs will ever get to a point where they can take 100 million rows and answer a question about it more efficiently than just an LLM that can write a query, for example. Not ever, but just like even like at least LLMs in their current instantiation, they're not like structurally set up to handle data in that form. Large context, what kind of like poisons this whole discussion around context is to what extent does structuring your data actually get you to better outcomes? To what like what is the, maybe the question is like, what is the LLM even doing behind the scenes when it parses this? Yeah, we could talk about what was the term, like context, whatever, the context fidelity. We could talk about that, but I don't like there's got to be like precise ways not only to measure that, but to define what buckets and categories of context fidelity you mean, because there must be some massive world of variance along many, many vectors that describes this space. What I'm making makes sense. There's like basically there's a tension between LLM structure and structured data, and like very clearly in a limit as you approach infinity. Just try to speak more like a physicist. In the limit as you approach infinity, the LLM will be worse at processing tabular data than a SQL query, or than an LLM writing a SQL query. Correct? If
what you mean by processing the data is it looks at it line by line and tries to do a mean or a sum or something like that, then a system that is designed precisely for efficient calculation probably is almost always better, because I think just the raw LLM is effectively probably fine at just memorizing how to do things.
Yeah.
The analogy that I just came up in my head is, there's this famous story about Gauss, the mathematician, of he was like, I don't know, 5 years old or something, and then the teachers, to punish Gauss and his classmates, said like, hey, add up all the numbers from 1 to 100. And then Gauss did it in like 5 seconds, and it was supposed to take like, hours. And then, the teacher asked like, how did you do it? It's like, oh, I realized that by adding 1 plus 100 and then 2 plus 99, they all added up to 101. So I just did 101 times 50, and then it's 5,050 or something, whatever it is. And then the end. LM is not doing the Gaussian trick to add the numbers cohesively. It's just doing things in a super brute force way. But because it has so much computational power, it could do it in the brute force way. So I guess one could argue that the LLM could do almost everything, but it will just do it very slowly. But and humans can't do it because they just don't have that much memory and computation power. But an LLM could do it, but like a query engine would do it a lot faster. So just because, I guess what I'm coming to is, just because the LLM could do it itself doesn't mean that the LLM would do it efficiently. I guess one way to think about why LLMs are so powerful is because it has like almost infinite recall of information and like things that it could do, but doesn't mean that you have performative recall on everything, right? And so from that perspective, if you want performative recall, you need an agentic software system where you have agents that also could call tools, like basically headless software and agents working together. And from that perspective, naively putting everything into the context window, it's almost tautologically not the thing that you should do. What you should do is you should leverage that context window so that the agents could call tools much better with much higher fidelity context. So I guess that's how you would construct the space. To get to maximal recall with highest performance is you need tools and you need maximal recall LLMs with maximal context window length.
Yeah, I love it. I like performative recall. That phrase.
Performative recall. Okay, good. See, we're coming up with good phrases.
Cool. TM trademarked. You watch this before we get to do it.
So I guess for LLMs, I think the TLDR. Now we're summarizing. TLDR is the beauty of LLMs is that it has almost infinite recall, and then to have infinite recall, it definitely is advantageous to have a very long context window to get to that performative, get to that infinite recall. But to have performative recall, you need to have tools. So the context window is helpful insofar as it extends the recall of the system, but it has limitations on the performance of that recall. Okay, there you go. So it's sort of categorically false that more context window equals, better performance. That's just categorically false. Okay, in general. That's why one needs to, I guess, think about things in a more rigorous way. Good. So it is true. It is true in general. More context, the better. And you could also construct pathological examples in which this is not the case. But on average, this is true. But I think for performative recall, you need tool calling, basically, like headless software. And that's like another layer on top of this. So you can't just reason about things just purely on context window alone. And that's like a very naive thing to do. Good.
Yeah. That's right.
All right. That was only the first topic. Second topic, open weight models from OpenAI. Finally, OpenAI from OpenAI. What does this mean for us and for data folks, Robert?
Thank God. I mean, yeah, let's talk about this. For us, the immediate thing is now, we built our platform mostly following OpenAI's lead against their API. And they have a lot of convenient things like tool calling and structured outputs that a lot of the other LLM providers just don't either implement or don't implement well. And the great thing now is anyone who is on any vendor, on any cloud vendor, can now use OpenAI. And so we're not. What's really interesting is like there was this early on in the history of LLMs. It's like 6 months ago. History, like there were some interesting dynamics where cloud vendors were basically taking bets on specific models. It's just like OpenAI, Azure, Claude, AWS, whatever. And now OpenAI's move is massive because the walls are now broken between cloud vendors. Like now it makes me a lot more bullish on OpenAI simply because they now have this way to like cut across those paper walls. And yeah, just basically convenient for us. But what do you think, Joseph? What does this mean? I think what I would want to know is what feels like the extrapolation to me is that like OpenAI will potentially win here because like they have the best API. They seem to still have the best model. And they're the first to move to this open paradigm, meaning that they're the first that can be implemented cross cloud vendor. And that feels like a very dangerous place to be in if you're, say, Anthropic.
Yeah, I think OpenAI is the proper noun in the LM space, in the AI space, the new AI space. And certainly that has a lot of brand effects. So I think a lot of folks outside of the US have heard of OpenAI and Sam Altman and ChatGPT, but not Anthropic and Claude. I think a lot of folks just don't know what Claude is. Yeah. Claude is really good for, I think it has positioned itself marketing wise that it's really good for code gen and it's good for enterprise and things like that, which is true. And also is the positioning of the company. So from that perspective, the fact that there are open source models, I think they released 2 of them, one smaller one and one larger one. That means that OpenAI could leverage its brand power and positioning to push forward this open weights model and try to beat out open source competitors like DeepSeek, for example. I mean, we were looking into DeepSeek as like a pretty good starting point for our models as well, but that might not be the case. And I think also one thing that folks are overlooking is that a neural network is very bare bones in terms of the architectures. And there are a lot of things that one could do to make the experience much better in terms of adding a bunch of layers on top of the bare bones neural network. And then whoever gets to define the set of APIs on top of that might have a massive advantage, right? And like one example of this is Anthropic owning this MCP server layer or this MCP protocol, so that everybody has to adopt this one and not OpenAI's protocol. And OpenAI even is supporting MCP. So I think owning that standard, the API standards on top of the LLMs itself, will also be very important as well. And then I think from our perspective, in our research, OpenAI still has really good APIs on top of their models, and they made it quite easy to build on top of it as compared to smaller vendors, let's say. It's smaller model builders and providers and so forth. So I think the power of that brand will compound in this direction as well.
I mean, even the big ones, for what it's worth. I don't know if you remember, but in the early days, we tested Gemini. And we encountered issues with their tool calling, where the tool, you can give it instructions to use a tool, but with Gemini, you just end up with, okay, the tool is called 50% of the time, which is terrible. Like you can't do anything with that.
Yeah.
Whereas the consistency from OpenAI is phenomenal. I have not yet encountered a situation where we've asked it to do something and it hasn't executed the appropriate tool, which is insane.
Yeah, it might be that maybe things are better now, and then thus, perhaps, a few months ago, a few months in the AI world is a very long time. So maybe things may have shifted since then. But the compounding happens so fast that having like a 6-month lead on something is certainly extremely advantageous.
That's right. And plus, there's also the Google effect. Like Google is not ever particularly fast on these things. I wouldn't make that that they've caught up. But
Right.
next week I can go look into it and see if they fixed it.
Yeah. So important thing for the whole industry, and certainly using OpenAI as a branching off point, as a starting point to fine tune proprietary models, and then being able to host this inside your own VPC. This is going to be a very, very important point for application builders like us, and also the companies, our customers themselves.
Yeah.
This unlocks a lot of different things. But I think one thing to note is that there's a difference between open weights and open source, and of course, open source, this is akin to licensing in the open source world. So are you fully Apache, if you're fully MIT licensed, or some weird like Elastic license that you prohibit AWS from fucking stealing your code and selling it, that type of situation. But for whatever it is, whatever reason, maybe it's a combination of goodwill and marketing and all these things. Usually, if you're going to go open, I think the lesson that we have learned from the open source community is that you better just be completely open. And maybe hedging as an open weights model it's not a good thing. And that's the counter against OpenAI having the open source hegemony versus the Chinese models, for example. And this is China's moment in terms of there is an opening here to actually try to win in that open source game.
Yeah. It's interesting because I think I generally agree with you, but there's a weird balance that there's a debate that goes on in my head around this where I'm like, okay, OpenAI though is the standard. It's open enough.
Yeah.
But let's see. It'd be fun to see how this plays out, especially if one of the open source ones really rises to prominence some way.
Right. Yeah. We'll have to keep on following the news here.
Yeah, for sure.
Okay. Let's move on to our next topic. We read something from Twitter that says, and I'm paraphrasing here, I've been surprised and impressed by how all of the leading agents are essentially while loops with LLM plus tool calls. And I think this is a sentiment that we've been hearing from a lot of different folks on social media and folks that we talk to on a regular basis. And what is surprising here is that you would expect that agentic systems are more complicated in their logic, and then maybe these agentic systems have some sort of secret sauce. But if it turns out that you're just running a while loop with the LLM deciding what to do next, then the power of the logic lives inside of the LLM, which gives less power to the application providers, and then a lot of the power is focused on the LLM itself, the base model itself. So then the question is, why are folks even building applications in the first place if the LLMs are commoditizing this type of workflow or workflow logic?
Yeah, it's such a good question. I mean, I imagine a lot of them are just doing it because they didn't anticipate. They didn't anticipate the LLM getting so much better, such that you can delegate the logic to it. But I think what's super interesting about this is that, okay, for us at least, there are situations where we do give the LLM or are planning on giving the LLM full reign to decide the logic on its own. But on the other hand, we do have systems where we're not doing that at all. And namely, we have our workflows paradigm, right? And I think there's a very clear tension between these two bits of the world where in one, you're giving the control flow to the LLM, whereas in the other, you're holding that within your own system, like you're controlling that yourself, and therein like letting the LLM kind of act as an interstitial thing within that the process of that deterministic logic, but you're controlling the logic in order to kind of gate the entropy. And I think what's interesting about this is that there's a very clear trade-off here, and I think people are really excited about this world where the LLM can kind of run a company, like basically like make the decisions, like run the queries, take the actions. But there's another world where if you want to have a bit more of a measured deterministic performance from the LLM, you have to take ownership of that logic and define it yourself. Essentially, there's a trade-off here between flexibility and discovery versus entropy reduction. If you want to
Yeah.
have a production grade system that reduces entropy sufficiently that you can rely on this, you can't let the LLM control the logic. But if you're just trying to discover things, of course, it's totally appropriate to let the LLM, and it's probably better. Like, you should let the LLM kind of have free reign as to what paths you should take for exploration.
Is this like the mean variance trade-off, but for
Yeah,
control flows? It's
it kind of
like
feels
that, right?
like it, doesn't it?
Yeah, so
like
it's kind of a trade-off where if you want extremely high precision of the control flow, basically if you want determinism, then you have to bake that in. Otherwise, you let it kind of have its free reign. And so if you have free reign, you kind of have higher temperature, so you could actually span a larger space.
Yeah.
And then with less precision, so higher recall and then less precision. And then for high precision, low recall things, you want to structure it, and then by having both of these vectors, like having both of these basis vectors available, you could actually span the entirety of the space, and depending on what the situation is.
Yeah, that's right. And it might be a little bit skeuomorphic for us to say all this, because, like, of course, this is trying to like fit LLMs into processes that companies have kind of inculcated for themselves and constructed for themselves. And maybe the optimal company is one where you just let the LLM do everything once the LLM gets to a point where it can. Context window gets big enough, ingest all the context of everything within the company, and then just let it make decisions and do analytics and then take actions. But at least within, but even then, like, if you want to, if the agent would have to create systems, and those systems would go into production, and those production systems must have some level of constraints against them so that they're not so brittle.
Yeah.
Like, you can't have an ETL pipeline where the ETL step is like one where the LLM is like, all right, let me take in this, like, here's a piece of data, like, put it into this table. Here's a piece of data, put it into this table. I mean, you can, but this kind of goes back to the performative recall point, right? There's like a massive performance degradation if you were to let the LLM do this. It's like hiring a human to manually write records into a database.
Yeah. And then the human sometimes, like 0.01% of the time, it just gets angry and decides to like delete the entire code base or something. Like, you just don't take the chance. Yeah, you just don't take the chance, right? So from that perspective, I think a lot of folks will feel a lot better, even if the LLM could do this particular task 99.99% of the time.
Yeah.
Like, why take the chance if you could just make that a deterministic step, right? And then just make it work 100% of the time.
That's right. So, and I think this is where, like, and I don't know if you agree, Joseph, but like LLMs, I think just there's just a ceiling. There's like a reliability ceiling on LLMs. And so you can't build everything out of LLMs. And as a result, you need additional, of course you agree, like, we're building this company together, but you need additional abstractions such that you can surpass that ceiling, right?
Right. Even from a performance standpoint, I mean, you could argue from a product standpoint, you need different interfaces. Humans want to use interfaces that they're familiar with. You can make an interface argument, you can make a product argument, but I think we're making an even easier point, which is even from a performance standpoint, you can't do everything with an LLM. You need structure around that, and you just need some amount of what we call headless software, which are effectively tools around that.
That's right.
Yeah,
that's right.
Yeah, this makes sense. I think we need to think more about this trade-off and maybe formalizing this trade-off a little bit, which I think for us, one form of that is the precision recall trade-off. There does seem to be a trade-off here, really. If you want a high precision system, you are definitionally, not definitionally, but almost definitionally looking for lower recall here.
Yeah, that's right. That's right.
Yeah. Okay, interesting. Okay, let's move on to the next topic. We heard from folks in our network that there is a data company in which the value proposition of that data company, and this is like an agentic data analytics company, the value proposition is that, hey, we could join together hundreds of data sources much better than competitors against like Snowflake and Palantir, et cetera, et cetera. And I thought that, we found this a little bit strange in terms of the value proposition.
Yeah, why is it strange, Joseph?
I guess this is strange because I think this might be implicitly saying that finding the unknown insights from the haystack, so finding the unknown needle in the haystack problem is way more important than doing known things on known data, but faster and better. So I think that it's implicitly making that assumption. And I think that it might be implicitly saying that in that case, a deep research paradigm is the core value proposition of that type of system, which I don't think it was said explicitly, but that's how I read it.
Yeah, it's strange because, and it's just help our listeners make that logical leap. If your value prop is to join together many data sources, you're clearly not doing something that you constructed one big table for say like your core metrics or your core dimensions. You're doing something inherently exploratory where you have a ton of data. You want to see if there's something there to answer to answer whatever more deep questions that you might have. I guess even before that, it feels odd as a value prop simply because, there's doing deep research, but you could also do that on your core tables. This is a question of like, can I not only do deep research, but do deep research against the long tail of tables that I have and find something that is more valuable than the Pareto optimal tables. And I mean, just to play devil's advocate, again, back when I was at Wayfair, we made I think I can share this, but it's been long enough. We made a model for ad targeting, and we found that like the most prominent feature to determine whether somebody would buy, not whether someone would buy a couch, but whether they would buy a couch if given the ad, compared to less whether they would have bought the couch without the ad. So this is like the uplift. The strongest feature was whether or not they had gone to like an MMA site recently. And just to be clear, like it was exceptional. Like we went from like zero lift on the models to like, I don't know, we were making like tens of millions of dollars.
Wait, did it just say that actually it was negatively correlated, meaning
exactly
causal?
Yeah.
Negatively causal in the sense of like, it's better to not show the ads to the people.
So we spent less money, we stopped serving them ads, and our lift went fucking through the roof. These people just really hate seeing Wayfair. Like, there is precedent here, right? Data companies, data does, there are needles to be found in haystacks sometimes, right? But I don't know, like this also flies in the face of, yes, we generated a lot of money by finding that single feature, but that was also really, it almost felt like a black swan moment, not like a repeatable, whereas like usually most of the value that an organization gets from doing any sort of data work is like, you do the reporting, you build the dashboards, you share the like obvious insights. We should not have this step because our funnel conversion drops off massively here, and if we just remove it, we'll have better funnel, right? Like, and I've seen that story play out a ton. Like, and in terms of like the number of times I've encountered a needle in the haystack solution to the number of times where like a Pareto law following observation or insight led to outsized impact, it's like 1 to 100. So like this is what makes me very skeptical that this could be the core. This is like the core thing. But then beyond that, of course, is a question of like generally deep research, exploratory insights, as opposed to more deterministic value from something like reporting or other automated functionality that we could implement with something like Oxy. And that I'm less certain of. I think people have found value from both, and I'm not. First of all, like deep research itself it's kind of a wildly chaotic thing where you're calibrating the intuition of many people by finding some random insights, and then that might change decisions down the road. But it's like the attribution model is dog shit, right? Like it's not like you can say, oh, because Robert found this insight about one of our funnel steps that led to us like serving ads against this other part of the, like it probably happened. The mechanism is probably chaotic in that sense, but the attribution is terrible. Then on the other hand, actually, general analytics is kind of like that as well, but I think it's a little clearer.
I think we came up with this fundamental theorem of data analytics when we were, now I'm calling it that, we didn't call it that. I think the fundamental theorem of data analytics while we were running hyperquery was that in general, the principal eigenvector that describes data analytics is building a data application.
Right.
Is productionizing a data application is the first eigenvector, meaning that that's like the most important thing that the system is doing. And from that perspective, it does not seem like deep research is building a data application is still in the realm of exploratory and ad hoc data analytics. And so while it should belong to the same platform, it's very hard for me to make the bet that that is the killer thing that one should be building in an agentic analytics system. And this is where I think a lot of the folks that are focusing on text to SQL or text to data or talk to data, all these systems as the primary wedge, I think while this gets people talking, and that is something that folks could understand easily from a consumption perspective, this may not be enough. And this brings us to our notion of, yes, deep research is important, and we also think this is important. While this is important, I think we ascribe to the philosophy of building a hyper compound system wherein you have many different slices and components of the job to be done in a single platform. And I think a company that we get inspired by, there are a few companies that we get inspired by, but one such company is Ramp, I think, with all of its automation. And despite it going down several times and annoying the fuck out of me, customer support has been quite good. And I think a lot of the automation features that were available piecemeal in like Expensify and like Brex and everything, I think these are all available under one platform. And the con is that things break constantly because it's a pretty complicated platform, but just the nature of it being all in one, it keeps us in there. I guess Notion is such a system. Figma is such a system. Rippling is such a system. I think we used to use Rippling with other tools to try to chain things together. But if you wait long enough, then Rippling itself will build out the features inside of the platform. There are real advantages in building a hyper compound system, and I think deep research is definitely one part of such a system. And I think that's our view. It's the anti-Y Combinator view on things.
Yeah, for sure. I mean, I think I've said this before, but it feels like some of analytics is about finding insights, I suppose, but you could also frame analytics as kind of being about determinism in a sense. Like you're trying to reduce the error bars on your actions inherently. And I think a lot of that has to trickle down to the way that you construct and produce data artifacts and ingest from data artifacts. Like there has to be, like determinism has to be baked in. Otherwise you're missing half of the.
Do you mean repeatability or
I guess I mean determinism, like as in like, I mean it in like a kind of a vague hand wavy way. There's probably a better word for this, but I need to ask Claude. But I guess I mean first of all, within your analysis work, that's where it manifests as essentially repeatability, reproducibility, which is like a first tenet of any analysis, as we know. But then I think even within the decision-making process itself, there's something about like the decision being able to be anchored. Like things kind of build up hierarchically in any sort of like reasoning process. And you can only build up hierarchically if you have like a stable footing on which to do that.
Yeah.
And I think a lot of that comes from maybe we can just call it reproducibility, but ensuring that like this thing is stable, that it is a thing that you can trust, that any of the branches that you take off of this path are not going to get axed off because you made a mistake.
Yeah. Are you saying that the way that humans make a decision is through a formal system, and this formal system is using language and logic? So logic with the use of the English language, and that's how people make decisions. And in that hierarchical chain of logic, the fundamentals of those nodes have to be stable so that you could construct this cathedral of the logic to make the decision. And
yes.
And it's much better to have a solid deterministic piece in that logical chain rather than something that is, may have some positive qualities, but is wobbly because it's more probabilistic in nature, or less explainable in nature.
Exactly. Like a pure deep research construction of this hierarchy would be one where every node now has a probability of failure. I mean, of course, like you could insert humans in the loop to build up the analysis, but the better system would be one in which like the system naturally builds up primitives that can act as the nodes in this reasoning process, and then like the edges in this reasoning process. I don't know how to give the analogy, and then like you have this constantly improving base on which to do the more like flexible reasoning steps, or like even to do the more deep research stuff, right? Like I think there's a world where if you construct more deterministic elements, more vetted elements, your deep research naturally gets better. Like the trustworthiness propagates all the way down.
I see.
There's a function here. There's an objective function that I'm trying to define here, but it's not.
I mean, the objective function I think is fundamentally
correctness,
making the most optimal business decision based on the synthesis of the data. And if you believe that better business decisions are based on this logical formal system in which being more deterministic is highly advantageous, then it follows that actually, if you think that your data analytics systems is about deep research, then you profoundly are misunderstanding what the decision making system is supposed to do. It's supposed to use a formal system and logic to come to decisions. And of course, there are counterexamples like you just make a decision based on a whim and like based on some intuition and some anecdotes. Anecdotes, like making a decision based on anecdote, it does follow some sort of formal system in the sense of like Jeff Bezos, I think he's known to say, look, if there is data and then there's anecdote and then they differ, go with the anecdote. That is also a formal system of like, okay, we have constructed this such that in general, historically, this is true. So that's also kind of a formal system, but that formal system is also based on like historical data and logic, right? So I guess from that perspective, maybe relying on deep research or even text-to-SQL as like the core anchor point of your agentic analytics platform has a profound, that if you're doing that, you have a profound misunderstanding of like what the decision making process looks like.
Yeah, which is why we always had issue with the entire text-to-SQL space, right? It's like, I mean, even by definition, if you define yourself as a text-to-SQL tool, you've anchored on that as like your underpinning, but that's fundamentally problematic.
Yeah,
it should be a fallback, not your default stance. But
right, and we do think it's important, but let's see how this pans out. Okay. Next topic, and maybe the final topic, is the topic of observability. I think in talking to a lot of our customers and potential customers, we realize that having observability baked into our system is quite important. And what we mean by observability is a little bit different compared to the general notion of observability, right? I think folks are talking about evals and testing and things like that. I think evaluations are words. Evaluations as a word is something that folks are saying to indicate observability in some sense. But I think we like the term observability better. Could we break down the different notions of observability that we want to bake into our system?
Yeah, and you had a some great terminology here, so I'll pass it back to you in a second. But I think like the way that people typically think about this is like, observability systems are historically all about things like downtime and cost, right? You look at how many tokens you're generating, how much that's costing you, how much money you're spending as a result, and then on the downtime side, like how much uptime you have, how much downtime you have as like a running measure against time. And I think that the industry is still kind of stuck in that mindset, and doesn't have a rigorous definition for how to deal with LLMs, when LLMs obviously start to impose much more ambiguity against the measurement space. So like there was this third term that, Joseph, maybe you want to talk about, but you termed like statistical observability, which I thought was like a very nice way to phrase and bucket basically all the measurement that has to happen that people actually care about around LLM-based systems.
Right. And that has to do with statistical notions of accuracy. And accuracy is a bi-directional thing in which, like the pedantic version of accuracy is a bi-directional measure in which you're just looking for whether you got the answer correct or not. But if you make things more unidirectional and like a little bit more fine-grained, then you could start thinking about things like basically sensitivity and specificity. So like in another way of thinking about things, then you're thinking about precision and recall. So more pointed notions of statistical accuracy. So if you think about agentic analytics and just agentic data analytics, data science, machine learning, this entire broad swath of agentic data systems, then you have to think about, okay, of the questions I asked, how many questions got covered by the answers? Answers might be, a little bit wrong, but maybe they were covered. Or like the answer is partially wrong, but at least a correct answer got covered. You could think about these things, that these are more related to the notion of recall. How many things can I recall? During my labeling process, a retrieval process, and then it's a notion of precision. How precise am I? Given that I answered this question, how precise am I about the answer? So there's that notion in statistical machine learning, like classical machine learning. There are notions of like the area under the curve as like a simplistic way to measure how robust your cutoff metrics are in defining your systems. Higher area under the curve of the receiver operating curve, is generally better. So there are many notions of this, right? And then there's also like, squared loss and just loss functions against some sort of objective function. There are many notions of this, and I think keeping track of this is quite important. Yeah. And I don't think any system, even OpenAI and Anthropic, they don't keep track of this. I mean, primarily because probably, they don't want to show it to the end user. It's not that helpful. And also, in some senses, it's leaking trade secrets. Yeah. But I think from our perspective, we want to do that for our end users and customers, because as a statistical system, it is very important to have trust in the platform that you're getting precise answers, and then also trust that you're getting enough coverage of the answer space. So at least keeping track of these two things are quite important to us. And then of course we could invent all sorts of other smaller metrics to think about, some notions of sentiment, some notions of how relevant is the answer to you, how concise is it. These are all statistical things that we could keep track of to give the best answer as possible. And not only that, I think the important thing for us is that these question-answer pairs could also feed back into our system, using reinforcement learning of some sort to make the system just better. Statistical observability is not just pure observability in the sense that you just observe things and then that's it, and you make some decisions or something. But technically, there is a way to actually take that information and then train this back into the model, inject this back into the model to make it better. So there is actually a feedback loop here that generally do not exist in software observability in terms of like cost observability or like downtime observability. There is no feedback loop that directly automatically goes back in, but for our system there is, and that's why that notion of observability is important.
Yeah, I think there's naturally like a trifecta of capabilities that you would want out of any sort of observability platform for LLMs. Like there's obviously the observability side, this like statistical observability side. I think there's also like a question of, if you deploy something, how can you be certain, how can you like rerun against the data that you've collected to ensure that any modifications that you make, like basically a testing suite, right? How do you ensure that any modifications that you make, you're not just playing whack-a-mole, fixing them all in one way and then like breaking it in another. And then finally, I think there's this reinforcement learning bit. And it all kind of, what's interesting is it does all feed off of the observability data. But I think this is what people are generally missing. Like you're missing all these components. You're not, I see a lot of tests where it's like, okay, let's just measure, measure sentiment, and that's like kind of like the main test you run, or like does this seem correct based on like term parsing or a source of truth. Like the most obvious thing is like if you have a source of truth answer, you compare the answer to the source of truth answer, correct? But I think there's something elegant here if you could build against these three worlds and construct something that more robustly allows you to see what's happening, ship changes, and then also like automatically make the system better. Like there's a very, very nice flywheel there. Yeah. We need to build a lot of stuff, Joseph.
That we do. And as a fun anecdote before we wrap up, I talked to an engineering manager from a large data catalog company today, and I think he agreed with me and our sentiment of, hey, just because you have a bunch of metadata and you put like an LLM on top of it, and suddenly you have agentic analytics and everything's gonna be golden. I think at least there is one player in the space that is rejecting the industry hype in terms of metadata LLMs. You're done. Yeah, it is not true. And I think the conclusion that we've gotten in terms of talking together is that if you have a data collection process that is very heavily revolved around, looking at lineage and, your source of truth for certain metrics and pretty much data analysts facing metadata, and then now you're thinking about building a system that is for all consumers, like business users and data analysts, in terms of doing the text to SQL or even deep research or vibe coding data applications, then you suddenly need a lot more metadata about how the metadata should be used for this agentic purpose. And then generally speaking, because the collection mechanism was for the data analysts, you just don't have this metadata. So you have to augment that. So because that's one reductive way of seeing why the current metadata platforms don't suffice in moving directly into the agentic analytics arena. But of course, things are adjacent. So it's a pretty natural point of expansion for these data catalog companies. But it's nice to have, some discussions that we have here, and then things get verified, and we hone our knowledge with our listeners and folks that we talk to.
Yeah, definitely.
Okay, there you have it. That's Agentic Data, episode 6.
Yes.
Good talking,
Good
Robert.
stuff.
And
thanks, Joseph.
We will see you next time.
All right. Bye, everybody.
Okay, bye.